Hello and welcome to SDN Tech Forum. In this video, I'm going to show you the packet walk for the entire DHCP process. On my screen, I have DHCP server, which is IP address 61.05 and MAC address E5A0. I'm going to start a Wireshark capture for boot P option 53, which is responsible for DHCP process, the DORA process, discover, offer, reply, and acknowledgement. And this is my DHCP client, which is Linux VM1. So you can see the ENS 192, that's the NIC, which is going to get the IP address, DHCP IP address. Right now it has an IP address, but we are going to release that IP address. So this is the Ubuntu command, which will help you to reinitiate the DHCP process. That means it just give up the current IP address and restart the DHCP process. Let me start the Wireshark here on my client as well, so that we can see all the packet coming live. So it says it killed the old process and did a DORA completely in 255 seconds. And on my screen, you can see all those messages, also the release message. Looking at client side is sufficient, but we will, just for sake of completeness, we will start this on server side. And in my previous video, DHCP overview part 1, I have shown you what router sees by using the monitor capture. And what we are going to do, we are going to drill into the packet itself and see different parameters. So you can see the layer 2 is source MAC address sent to the layer 2 broadcast, and layer 3, which is IP, is sent source address 00 sent to layer 3 broadcast all 255. It's a protocol, UDP protocol, since DHCP uses UDP, and source and destination all 0 set to layer 3 broadcast all 255. UDP layer 4 standard well-known ports 68, 67 server side and the client side, and then you have bootstrap. This is what we are interested in. So bootstrap, it clearly says this is a discover type packet, and hop 0, that means we don't have any relay agent here. Transaction ID is going to fix for the entire DORA process, and you can see the various DHCP options, right? Client IP is initially set to 0, your client is also set to 0, relay agent also 0 because we don't have any relay agent. Client MAC, the client is setting its own MAC address over there, and while broadcasting this. And also you can see the option 53, this is option 53, and this is sending a DHCP Discord message. There are certain other options sent also, like option 12, option 55 for some additional configuration, and we will see when the server reply what it sends along with the IP address. Because just getting the IP address is not sufficient, you need to know a few things as well, and we will look into that. Now let's check the DHCP offer message. Same thing, we'll start with layer 2. So layer 2, you can see that this is a E5A0 server sent to this client A408, MAC address of server and client. IP address, now you can see this is a unicast packet, that means 105 is my Ubuntu server. DHCP server sent to the client 6125. UDP port is not going to change, it's 66, 7 and 68. Again, the bootstrap protocol this is the offer type, boot reply, and you can see the transaction ID. And if you go down, you'll see the client IP address still 0, but DHCP says that use this IP, your IP address, and next server IP is set to himself, right? And no relay agent in this case, so which is fine. Client MAC address, DHCP knows that, client MAC address, and also you can see that it's sending some more details here. 10 minutes is the default lease time set. You can always customize that. Subnet mask /24, and router, which is my gateway, is going to set to 61.1, which is a SPI on layer 3 switch. And you can also send domain name and DP server and all those details. DNS is also my layer DHCP server, and one more DNS server I have in my network. So all this information is passed on to the client. Now client is officially going to request this IP address. So this is not a unicast again, formally going to request, but it broadcasts that. So it is broadcasted to 255, and my source address is still 0 because I want a formal confirmation from server. UDP is 6768, and you can see the bootstrap protocol is boot request. So I'm formally requesting now. Hop is 0, transaction ID is consistent, and you can see that requested IP address. This is the important field. So it is telling that this is the IP address I want to request, formal request sent to that, and also it is sending its host name. So server offered him IP, and now a DHCP server is again broadcasting to the DHCP server and requesting that formally. Now DHCP acknowledgement. This is a unicast from server side, and now let's look at the bootstrap protocol type. This is acknowledgement type. This is the what I wanted to show you around the DHCP different optional parameters or optional fields. RFC 2939 if you are interested, and these are the different DHCP type, message type, right? So 12 you have seen hostname, 53 is for DORA process, 43 is very important. This is a vendor specific field. So a lot of vendor are using this for option 43 for zero touch provisioning and PNP, and then option 82 is relay agent information in case of VXLAN programmable fabric. So DHCP protocol with such a variety of options code is getting more and more stronger. So earlier it was only IP address management. Now this is taking getting at a different level and doing much more than just the dynamic IP address management. And I hope this video was helpful.